Welcome to the HiveMQ IoT in Production webinar. We're happy that you will join us today. I am Verena. Next to me is HiveMQ Head of Support Florian Raschbichler, who will be the speaker today. We will start shortly, but before we start, I have some tips for you. You can ask questions during the webinar by clicking on the Q&A tab. Questions will be answered either during the webinar or afterwards. And there will also be a poll during the Q&A session. So we would be very pleased if you could give feedback on the webinar and answer the poll. And also for your information, we are recording the webinar and we'll upload it on YouTube. And there's also the chance to already register for the webinar that will be in December. So now I think we're ready, and I would hand over to you, Florian, to start the webinar.
Thank you, Verena. Welcome, everyone. My name is Florian Raschbichler, like Verena said. I am the head of support at HiveMQ. That means I am responsible that all our customers get outstanding technical support with their MQTT and HiveMQ deployments. And in that role, I also provide operational consulting for our customers. I have, since working on the MQTT topic for more than 5 years now, guided more than 120 customers to their production use cases. And today's session will be about the lessons I learned in doing so. So we're going to have a quick look at the agenda of this webinar. I will have a very brief overview over what MQTT is. To those of you who are looking into a more in-depth explanation of MQTT protocol itself, I can recommend our YouTube channel. You will find the webinars of the last 2 months there, where our CTO, Dominic Obermeyer, speaks about MQTT and the new features in MQTT 5. Then I will demonstrate an IoT use case that I have seen more than once in real life, and we will take this use case to talk about what are organizational hurdles that come about. What do you have to think about when testing IoT deployments, debugging the same? We will have a look at IT security implications of large-scale IoT deployments, and we will have a little bit of a closer technical look into the networking infrastructure and what to consider there. And then afterwards, after a short conclusion, like Verena said, there will be a Q&A session, and I will be happy to take your questions. MQTT, as of today, can be named the de facto standard protocol for communication in IoT. Evidence is the Eclipse Foundation IoT survey, which found that most IoT use cases actually use the MQTT protocol, even ahead of the HTTP protocol. And in our everyday business, we help our customers actually move, in many cases, move away from HTTP and move to MQTT. Why we do that and what the advantages are, I will talk about a little bit shortly. Also, you can see the Google trend in terms of search terms, and you see that MQTT is very much so on the rise. Very broad overview of how the protocol works. It's a publish subscribe pattern that is observed. This means that the sender and the receiver of messages are decoupled, and all communication goes via the one central component, the broker. And yeah, it's a very lightweight protocol. That one of the major characteristics that MQTT has is that you can have guaranteed message delivery even in unreliable networks, as well as the networking overhead and the implementation efforts on the client side are very lightweight. Okay, so we will be looking at a very specific IoT use case where I can demonstrate to you, or I can let you know how it comes about that our customers want to actually remove HTTP out of their IoT protocol stack and replace it with MQTT in many cases. Imagine the following. You are on your way home from work, looking for a ride share, for a car share. It's raining outside, it's cold. You're standing in front of the BMW that you're going to rent via your car sharing application, and you press the button, and it takes up to more than a minute for the car to open. In a scenario where I'm not sure where the listeners are from, but here in Germany in mid of December, end of November right now, this could be very uncomfortable standing in the cold and in the rain for more than a minute. But this is how long it takes getting an HTTP request from your mobile app to your car. And when switching to MQTT, this time can be reduced to sub-second. This is one of the reasons why many connected car use cases are amongst our customers, and most of the lessons learned today will be relating back to the connected car use case. So not one specific use case, we have multiple customers that do this, and I have basically gathered multiple lessons learned in multiple deployments. Now, here is a quick overview of how the architecture looks. This is, again, a broad observation of it. So we have, on the left side, we have our devices, which can either be the mobile applications of your customers or the actual cars. In the center, we have the MQTT broker cluster, which is connected via a load balancer. And on the right side, we want to demonstrate actually the back-end server structure of your company. So in this case, on the one hand, we have the back-end system. And then you also can see that the OAuth server, which is an authentication mechanism, is not connected via MQTT, but is directly integrated with the HiveMQ cluster. As demonstrated, the connected car use case is, I like to see it as the hello world IoT use case, because you want bidirectional communication. So you can, on the one hand, gather telemetry data from your cars, but you can also send commands like opening doors or starting ACs via applications. Of course, cars by nature want to be mobile and moving, and therefore the networks are unreliable. And also one of the good things is that cars these days, of course, they're like driving miniature computers, so we have a decent computing power actually to implement use cases. A recent survey actually from 2018 showed that across automotive executives, connectivity and digitalizations was the #2 importance. So this also explains why basically all your big time OEMs in the manufacturing space are introducing connected car capabilities. And yeah, also we actually at HiveMQ, we talk to the OEMs directly, and all of them, they view themselves as technical innovators. So they want to be, of course, on the forefront of IoT. And then the user experience can be improved using IoT technologies. The one example I gave at the very beginning was quicker commands that can reach to the car when using MQTT. Another very promising example from my personal experience is with modern technologies, actually premium services for navigation can consider traffic light rhythms when guiding you through a busy city like Munich or San Francisco, which of course provides a very cool user experience. Okay, now that we talked about why we're looking at connected cars, and let's talk about the lessons that we learned. So first of all, before I want to go into too much technical stuff, I want to talk a little bit about operational hurdles. So these points that I will be making do not only apply to IoT use cases, at least some of them, but they are specifically for enterprise scale deployments. So one of the challenges is that there's multiple teams and multiple vendors involved in an entire IoT deployment, like the connected car use case we're looking at. This is due to multiple factors. Of course, we have very new technology here. Knowledge is typically spread across multiple experts that are subject matter experts on their very specific field, and responsibilities for different components might also be spread across multiple teams or even multiple vendors. Challenge in still getting to one common goal is, how do you communicate who is actually accountable, and how do you synchronize? Typical pitfalls, of course, are in friction loss in terms of communication. Sometimes important information gets lost. Don't fall into the trap of playing the blame game, and sometimes resources can be blocked if not taken care of preemptively. So what are the solutions that I've seen implemented that really help with this hurdle? So you establish points of contacts that are not on a managerial or commercial level, but really operational level. So allow your developers, your operations guys to talk to each other. Find someone in the mother company that has the overall ownership, and make sure to coordinate needed capacities early on. Another challenge that comes with adapting to IoT, or adapting to IoT comes with a few challenges. The technologies are new. The projects typically are very long-term. IoT, the T stands for things, so there is usually also hardware production involved. And companies try to conquer new territory. Typical pitfalls that I have seen multiple times is that companies start doing without doing a proper knowledge transfer before. They do not actually consider the long term, and they lack of foresight. And technical one-way streets, what I mean by that is technical solutions are pursued that then in the long term turn out to be wrong, and you can't go back. So it's a one-way street. How do you combat these pitfalls and challenges? Well, you hire experts in their fields. You do really invest in architectural consulting, and you go to the experts that help you in the architecture of the unknown space. And this last point, this is very important when choosing your software stack. And in the IoT space, there is lots of options out there. You can go open source, you can go commercial. Make sure that if you go open source, that you can maybe still buy support for the open source, or B, do not fall into the trap of choosing a technology only because it has a lot of stars on GitHub, and in reality, it's actually one single person after work on their couch maintaining this repository. This is I'm bringing this up because this actually happened more than once in the 5 years that I've been doing this. So really, really make sure when choosing your software stack that the software you're choosing is maintained and supported properly. Okay, now that we took a look at operational hurdles and general problems, or not problems, challenges, let's take a little bit more deeper look into testing IoT deployments. So I want to state this, and I'm going to probably state this more than once, you cannot overestimate the importance of testing. Generally in software development, but for IoT, it is especially important. Proper testing will automatically improve your customer experience at the end. You do not want your customers in these new premium technologies and services to be your beta testers. All of this becomes even more so important when we're talking about the actual device, so the hardware that has to be built. Okay. You have to consider end-to-end when testing your IoT deployment. It is important to test scalability when you're talking about connecting millions of cars together. Resiliency testing is, of course, very important. High availability for your components, having the capabilities of dealing with problems in your infrastructure. And of course, you want to make sure that your system has the performance that you want. So now here's the pitfall that I have all too often seen being tripped over, is that we talked about it in the beginning. We have multiple vendors, we have multiple components, and it might make sense that all of these components individually tested fulfill the scalability and resiliency and performance requirements, or most of the components do. Please make sure to always do scalability, resiliency, and performance testing on the entire system. Very oftentimes I have seen that you scale test individual components and then you do just a smoke test, like an end-to-end. Okay, one message could have been delivered, it works. It really, really pays dividends, especially at the later stages of a project when we get closer to going live and going to production, to have a performance and a resiliency test on the entire system. Logically, your entire system in terms of scalability, resiliency, and performance can only be as strong as your weakest link. And without testing the entire system, you might not find out. In addition to the complexity of end-to-end testing and multiple components, there is also another difficulty layer brought upon by the fact of project staging. When we talk about complex IoT use cases, like the connected car use case we're trying to focus on, these are very complex use cases. On the final life stage, this will be cars driving around a city with all the mobile carrier and everything that comes into consideration there. So of course, the devices and the hardware and the networking cannot be tested completely in lower developmental stages. This is why I see the pitfall of companies switching over to complete lab testing software. So what I mean by that, you have everything is just simulated. You are not using actual hardware. You are not using the actual network. And in your lab, things might work out just fine. And then once you go to production, you realize that the live network functions differently in a specific kind of way. One of the more common cases will be part of this talk at the end. So to combat this challenge of project staging is use actual devices on a very early stage. In this case, have actual cars driving around and testing your developmental stages. It can really, really reduce the pain later on. The same is true for networking systems. And also, when testing your software, make sure that you plan your testing cycles actually around, of course, the hardware development, because typically the developmental cycles for hardware are significantly larger than they are for software. So make sure that the hardware gets tested and don't focus too much on the smaller implementation circle components like software. Okay, so now that we've got our deployment developed and we got it tested and now we're live, and now, of course, we are faced with additional challenges when it comes to debugging these IoT deployments. What are these challenges? Well, many of these technologies that are being used are actually what I like to call black boxes. What this means is that there is a lack of insight to the user. The large-scale IoT enterprise deployments that we are talking about here, like a connected car use case for a premium OEM, we're talking about immense amounts of messages. There's also, in Europe and the US, we have strict data protection laws coming in there. The scalability we're talking about, we need distributed systems. Single systems cannot handle this kind of load, and single systems also can usually not cover the amount of actual geographical space that we are talking about. And once again, the subject of unknown technologies comes up in debugging. So what is the pitfall here? You're trying to debug. Imagine, for example, your customer complains that he booked the before mentioned premium traffic light navigation service, but it never arrived on his navigation system, even though the money was transferred from his account. So how do you figure that out? Well, if you have mute components that do not talk about what they're doing, so what I mean is like have logging statements, have traceability, it will be really hard to find out what was happening. If you're using an unknown technology from a vendor you don't know and you didn't have a knowledge transfer before, it'll be very hard for you to actually provide proper support to your customers. And especially when debugging problems in stages before going to live, it's a typical pitfall to have hasty conclusions. So just because a problem is gone, or just because you don't see a problem anymore, if you haven't found out where the problem came from, doesn't mean it doesn't exist anymore. So gather as many metrics about your systems as you can. build a meaningful dashboard for your operational team that they can really extrapolate the health of the system from. When it comes to your logging solutions, we are talking about distributed systems here, have a centralized logging solution so that you only have to look at one place. Do root cause analysis always, even though if problems disappear. And then this next point is very important. So there's nothing you can do about data protection laws. Yeah, so at least not in the short term. What you can do is, if you're talking about earlier staging environments, you can have more verbose logging there. When you have test clients, when you're using your employees as for testing purposes, you're allowed to log personalized information, for example, like a vehicle identification number when talking about connected cars. So this is another reason why it is important, like I mentioned before, to use actual devices in earlier stages and do very proper testing. This all, of course, belongs together in some way. So do proper testing on proper devices in earlier stages. And this way you might find problems before it even goes to live, or you have already seen the behavior and you have some idea on where else you could look to find the needle in the haystack, so to speak. And of course, your operational team needs to know about the technology that you are using. So get them up to speed. Okay. So I've added a chapter about IoT security to this webinar because I've received many questions about it. And like we said, IoT technologies, IoT deployments, this is new technology. This is somewhat uncharted territory for many. And the ideas behind, is IoT actually secure or not, come up a lot. So we talk about here how you can actually get a properly secured IoT deployment. Of course, this is very important because at the end of the day, the device that you're connecting over the internet will in most cases be in the hand of an actual end customer. So any breach in your security will get you front page news, and the kind of front page news that you do not want. So here's how to avoid that. So security is always, and this is true for all IT security, but especially also for IoT use cases, a matter of layers. So you do need to make sure that your data is secure. And how do you secure your data? Well, you secure your application. And if you secure the application, you have to make sure that the host is also secure. And then when your host and your application is secure, you also have to make sure that you secure your network, of course. MQTT, as shown by this picture, lays on the OSI layers 5 to 7 on top of TCP/IP, and it can also be combined with TLS encryption. So additionally to MQTT on the application layer, we can also add TLS. So TLS is an encryption application layer protocol, which also provides authentication and can ensure data integrity. Through the use of TLS, we make sure that, or we can make sure, using the proper technologies, that only those clients can connect to our server that we want, and that the communication is actually encrypted. If you're using proper software like the HiveMQ Enterprise MQTT broker, typically you can even talk about doing mutual TLS. So this means not only does the client authenticate itself over the server, but the other way around as well. And we can completely eliminate the possibility of man-in-the-middle attacks there. Good. So we talked about encryption, and we talked a little bit about authentication in terms of using certificates for authentication, but I would really suggest doing additional authentication. If you remember back to the initial picture of the deployment, you thought that we had an authentication server directly integrated with the MQTT broker. And so this server typically uses existing infrastructure like an LDAP or Microsoft Active Directory or OAuth 2.0 service. All of these already existing security measures within your company can be leveraged for proof of identity of your clients. And it is important to note that these features do not come with the MQTT protocol itself. The MQTT protocol itself comes with the basic authentication of username password, but with the right software and with the right extension system like HiveMQ offers, we can leverage these fields to integrate, for example, the OAuth 2.0 server by passing on the Java Web Token in the password field of the connection. So once we took care of authentication and we are sure that only those people or those communication partners that we want to take part in our communication, the next step is authorization. So in my opinion, this authorization is also an absolute must. What this allows you is to really define, based on your clients, what can they do. So can they publish and or subscribe messages? Which quality of service levels can they use them on? And most importantly, which topics can be used? Again, when we are talking about the connected car use case, and you can actually open up the door of a car with your mobile application, it is absolutely critical that you can only do that for your own car. And you can ensure this by introducing authorization to your MQTT broker. Here's a very quick sequence diagram. I don't want to get too deep into it, but what we really can see here is that we can utilize the HiveMQ broker with a security extension to get permissions. So on the very right here, this is the permissions, and this can be any system like we talked about. So your LDAP, your OAuth can be the source of these permissions here. And what we see here is that during the connection establishment, actually on application level, we make sure that our client only gets the permissions that we want him to have. Some quick best practices when it comes to IT security in the IoT space. When defining your infrastructure, your networking, know which ports are being used and where your traffic is coming from, and then only open up the protocols and the ports that you need. So typically for an MQTT broker, this means that you do not use UDP, and the IANA ports for MQTT connectivity, for example, are 1883 for plain TCP connection, and the 8883 port for a TLS encrypted TCP connection. Once you make sure that your infrastructure is as secure as possible and opens up as little as possible, also, of course, make sure that your operating system is up to security measures. Use a security Linux distribution if possible, and always make sure that the libraries and softwares you're using are updated. Now, looking at the broker itself again, we talked about this. So you want to use TLS, you want encrypted communication. We want authentication and authorization to be used. We want to separate the topic namespaces. So when I talk about only you being able to open up your own car, to make that a reality in terms of permissions, of course, you need to make sure that the topic that the control unit in your car is subscribed to actually contains a unique identifier, which could be the vehicle identification number, or and then you can give permissions to topics specifically containing these unique identifiers. So this is what is meant here by separated topics by namespaces. Other security measures, of course, can evolve around making sure that your broker cannot be denial of service attacked. And two possibilities for this to happen are you can actually throttle the amount of connections that singular clients can open up. And then also, we really recommend that configuring a message size maximum that can be used on your broker. So the protocol itself allows up to 256 megabytes of messages, but in case you know that in your use case, none of the messages are ever going to be bigger than 2 kilobytes, then it makes absolute sense to not allow bigger messages than that. Because this can also lead to denial of service, either maliciously or even unintendedly by some misbehaving clients that maybe some software update is not up to date and they send 200 megabytes instead of 200 gigabytes. And of course, this can result in unwanted stress on your system. Okay, so now that we looked at what are the IoT security best practices, which is part of the production for myself, or I believe that it is, I want to take a look at networking. So talking back to my to the initial graphic, of course, it looked very basic, right? So the mobile application is connected to the load balancer, and the load balancer is connected to the broker, or the car is connected to the load balancer, and the load balancer is connected to the broker. Well, in reality, the networking infrastructure is significantly more complicated than that. And one of the more prominent challenges that come with that I have seen time and time again lead to unexpected behavior and hard to debug errors are TCP timeouts. So what are the challenges here in the IoT space? We have multiple components involved, right? So between the car and the load balancer and the broker, there's many more components. We have billions of devices worldwide that are connected over the IoT. And since IPv6 is still not really widely accepted, other solutions need to be found to find address space for all of these devices. And yeah, we're also talking about different layers. Okay, so what are typical pitfalls? Timeouts. So What I mean by this is MQTT comes with a health check timeout feature. It's called Keep Alive, that makes sure that the broker and the client stay connected by sending ping messages to one another in a defined interval. Now, let's say you tell your client to send a ping to your broker every 5 minutes, and you're connecting via a firewall in front of the load balancer. And this firewall has a rule on it that says every TCP connection where you don't identify traffic for 3 minutes, close it. Now you will lose your connection every 3 minutes without knowing why. And these kinds of considerations need to be made for all the components that are actually between your MQTT client and the MQTT broker. Netting firewalls. So without going too deep into network technology details here, so when you connect your IoT device with your typical IoT SIM card, this device will be part of a private network belonging to your carrier. But now if you want to make connections to the actual internet, there is components, so-called netting firewalls, and basically they will associate your private IP address to a public IP address for a certain amount of time, because these public IP addresses, they are limited. And these firewalls also typically have rules where if there is no connection sent over the firewall, the rules will be overwritten. And this is for MQTT, this is a challenge because we have standing connections. Then when using layer 7 load balancers that are working on application level, you need to make sure, you need to consider that quality of service 0 messages are actually one-way traffic. And also this might be a reason why a load balancer closes a connection, because it's only getting incoming messages from the clients without outgoing messages by the broker. Of course, scalability and resiliency is also a very big concern when talking about the network infrastructure. How do you find a solution to these problems, or how can you avoid running into problems with these challenges? Well, you need to make sure that your heartbeats are synchronized. So what I mean by that is all your timeouts need to be as low as the lowest timeout. So to make sure that your connections don't drop. Once again, we come back to live testing. These challenges can be found out, and then solutions to them can be found when you test with actual devices on your actual network. And it absolutely helps to create detailed overviews of your network infrastructure. So I want to come back and demonstrate what I just talked about just a little bit on this theorem. So this is of course this is a very high level picture, and the netting firewall that the SIM cards in the cars have is right about here, right? And so all the cars connect to this firewall in the public network, and then they connect to the broker from there. So, and with MQTT, we have standing TCP connections. So the source and the destination IP address need to be the same for the entirety of the connection. When talking about request response type communication like HTTP, this is not an issue. So if you're thinking about implementing an IoT use case using MQTT and using a typical IoT SIM card from any of the big carriers, please consider that the timeouts for the netting firewall of your SIM card provider is actually, usually the smallest timeout that you have to consider in your deployment. Okay, so what can we conclude from all we talked about? certainly, and this is demonstrated by, you can check out the customer list for HiveMQ. IoT is ready for production when done correctly. One of the biggest lessons that we've learned, that our customers learned, you have to acquire the knowledge and the expertise for the technologies you are using. So like I just talked about, the netting firewall phenomenon, you have to talk to someone who is actually an expert in IoT SIM cards, who is probably a consultant for a carrier, to know these kinds of things. And something that has been shown time and time again is the earlier you invest into a holistic approach on this. So the earlier you start looking at the end-to-end architecture, the better. And if you invest a little bit more time there in the beginning, you will save that time multifold by the end. All right. I'm at the end of my slides, and I hope I could provide some good information to you. So I see we just got a poll coming in, and I would kindly ask you to actually take part of the poll. And then afterwards, I'm happy to take questions.
Florian, this is the end. There's questions already in the Q&A panel, so you should start reading them off.
Okay. Yeah. So here are 5 open questions. So you can pick one.
Let's see. Okay, so anonymous viewer asked us, is TLS and auth strong enough to protect the IoT devices from being hacked, which is very common today? Okay, so that's a very good question. Thank you, anonymous viewer. When talking about IoT security, you have to consider multiple layers. So the TLS and the authentication that we talked about, they are to secure the transport layer and the application layer of your deployment. So this means that the information that is being sent between your devices and your broker is secured via the TLS, and you can also secure the broker from basically unauthorized access. When it comes to securing your IoT devices against penetration and against hacking, that is of course a host level or a machine level IoT security. So it's possible that you need to put additional considerations into that. But just to reiterate, so that with TLS and proper authentication, the transport and application level security should be sufficient. Okay, Shashank Sinha asked, how will the latency affect an OAuth2 authentication and authorization, and is the authentication and authorization called on every action? Another very good question, and the answer to this is quite well. So let me answer from the view of it is possible to use caching for the authorization of your MQTT clients So typically, the authorization will only happen on connection establishment, and then for the duration of the connection, the authorization will be stored for the client on the connection. So the latency is very minimal. And in terms of authentication, so OAuth servers, they typically, you will validate the signature against a public key set from your server. And these responses are typically also cached for about an hour. So the impact on the latency and performance of your clients should be minimal. And we also see this on performance tests we have done with integrated OAuth security. All right, another anonymous question here. Debugging network issues with IoT devices is difficult. Any good practices around it? First of all, I can certainly agree to that statement. Like I said, I run the support team for HiveMQ, so this is part of the business I deal with daily. Good practices around it. Well, first of all, you should, in my opinion, really utilize the proxy protocol wherever possible. What this means is that the original source IP address for every connection will be handed over across multiple components in between. So at least you can identify the actual source IP address. So this is one of the good practices that I would suggest. And then second good practice is use software with extended analytics functionality, like, for example, the HiveMQ enterprise version comes with trace recording, which would allow you to actually do debugging on the MQTT application layer to identify problems. Victoria Espinosa has two questions here, and I will happily, actually there's three questions. So let me do the first one first. So what are the best practices for IoT knowledge transfer inside an organization? So it's Victor, sorry, Victor. That's a good question. I don't think that it is different to any other kind of knowledge transfer. So what we do at HiveMQ, and what I've also seen customers of ours do, is typically there is a internal wiki, multiple providers for that. So we use the Atlassian stack of Confluence, but there's other providers. And then I can really recommend, having basically internal trainings. What kind of architectural investments would you recommend? Victor also asked this question. I personally would recommend finding a company that offers architectural consulting in the space you're looking for, and see for their trainings. So I know that HiveMQ offers these, but I also know that other consulting companies around IoT offer IoT architectural investments. Another good idea could be to visit expert conferences and visit talks about the subject. Okay, that's it for taking questions right now. There's a few more open questions. We will answer those afterwards.
In the community forum. In
the community forum, exactly.
So I think that's it. Thank you, Florian, for your presentation on IoT in production. Our webinar is coming to an end now. Thank you for joining us today. We hope you enjoyed it. And if you want to watch the webinar again, we will upload the video on YouTube. you can just click on the link in the chat and also subscribe to our YouTube channel so you won't miss it. You also find a link here to subscribe to the newsletter so you stay updated on the upcoming webinars. Like Florian said, we will answer all unanswered questions in our community forum. You will also find a link here. And you can already register today for the next webinar in December, which will be on the topic of the HiveMQ MQTT client. So I think that's it. And thanks everyone for watching. See you in December.